Stop scrolling. If you see a function like this on your calculus exam and it asks for the x volume of a solid of revolution, don't panic. Let's solve for k. We are rotating around the x-axis, so we use the disk method. The formula is volume equals pi times the integral of our function squared. So let's apply the formula to our given function. F of x squared equals x times the square root of the quantity 3 minus x squared. Now, here's the trick. Squaring a square root, just delete it. So, squaring the square root of the quantity 3 minus x squared will simply become 3 minus x squared. So, our new function after squaring it all will become x squared times 3 minus x squared. Let's distribute the x squared to get the polynomial, 3x squared minus x to the fourth power. Now, we can start integrating our function. So we have the integral from -1 to 1 of 3x squared minus x to the fourth power. We will be using the power rule to integrate our functions. For the first term, 3x squared will become x cubed. And for the second term, negative x to the fourth power will become negative x to the fifth power over 5. So, our new function after integration is v equals pi times x cubed minus x to the fifth power over 5. See? No more scary roots, just basic power rules. So now we are ready to substitute our upper and lower limit to get our total volume. Let's start with our upper limit, 1. When x is 1, v equals pi times 1 cubed minus 1 to the fifth power over 5. This is equal to 4 over 5 pi. Now we substitute for our lower limit, -1. When x is equal -1, v equals pi times -1 cubed minus -1 to the fifth power over 5. This is equal to -4 over 5 pi. Now, let's subtract the two values. 4 over 5 pi minus -4 over 5 pi. The negatives cancel out to give us a total volume of 8 over 5 pi. The question asks for the value of k in k over 5 pi. So k equals 8. That's it. If this made sense to you, hit that subscribe button for more math tutorials.